Everyone, another day, another Leetcode problem. So now we're going to be looking at 417 Pacific Atlantic water flow. So this problem statement is a little long. I'm just going to go ahead and show it over here to you guys so we'll get a better idea. So we're basically given an M to N grid. It's land, and this is surrounded by the Pacific Ocean and the Atlantic Ocean. And the way it's surrounded is so over here, we have the Pacific Ocean, and to the left and to the top, we have the Pacific Ocean, and to the bottom and to the right, we have the Atlantic Ocean. And now what the problem is asking us is, so it's basically telling us after it rains, there's a lot of water that falls onto the land, and the way for the water to reach the Pacific Ocean is if there is a cell that gradually keeps on like a value of, these are basically heights. So if the height keeps decreasing and it goes all the way to the end where the Pacific Ocean is or where the Atlantic Ocean is, it reaches that part of the ocean, and the water is able to flow. So if there is land that's actually like we can see over here, it's where let's give an example. So basically, right, so water flows when it goes downward, but if it's going upward, then that water ends up remaining there and that water never reaches the ocean. So if I were given a cell value over here, like something like 5, and after that it was 6, then 5 could never flow to 6. But if it was something like 4 and 3, then it would have flown down and it can go and reach the ocean. So yeah, that's what it is. And what they're specifically asking us is, if you check like this, all the cells, the land areas which can reach the Pacific Ocean and the ones which can reach the Atlantic Ocean, from which land area can the water flow to both the Atlantic and the Pacific Ocean? And okay, so we'll understand that here. So let's just look at the Pacific Ocean first. So this area and this area is where the Pacific Ocean is actually like the land is touching it. So that by default tells us that this row, this column and this row over here, these are in contact with the ocean, and everything that comes has to flow through this, right? And let's look at the condition that they've given us here. So the land has to be downward sloping, which means the cell adjacent to it has to go downward. So let's look at 2 here. It can either be downward or straight. So 2 has a value 2 over here, so it can pass through here and go to the Pacific Ocean. It cannot go from this side, because it's larger than it. Then there's 3. So 3 can go from here. It could go to this 2, but then there's a 3 over here, so that's a problem. So yeah, this 3 can reach as well. And then there's a 4, so this 4 can reach from here. And we have a 4, so this will actually, it can go from the Atlantic Ocean. So we'll check that for that. And then this 4 has a value smaller than it 2, which is at the periphery. So this can also go. Then we have a 5, 5 goes to 4, 4 goes to 2, this can also go. Then we have a 3, and I think that'll come. So it can go from this side, it can't go from this side. Will not reach the Pacific Ocean, but it will come in the Atlantic Ocean part. So that's not a valid example for this Pacific Ocean part. So let's look at 7. 7 goes to 6. Yes, it can reach. And then we'll look at 1. 1 cannot go to 5, so that's not a valid example. And I see the cell above it is not leading anywhere either. This is not leading anywhere. Then, okay, 4 can go to 3, but then it has a 4 again, so that's not valid. I think pretty much that's it for whatever comes to the Pacific Ocean. I think everything else is going to be the Atlantic Ocean. So let's check for the Atlantic Ocean over here. Okay, so we know that this here and this here are directly in contact with the Atlantic Ocean. So let's look at the cell. Yes, 7 can pass and it can go. 1 can pass, it can go. 6 can pass and it can go. 4 can also go. 5 can also go. This 3 over here can also go. This 4 can pass here. 3 cannot. 5 can also pass here. And then, so this 4 cannot go. But yeah, we can look at not through this 3 will not go. What else will go? So we can have some creative kind of paths as well if they are adjacently connected. But what else? So we have a 2 and 3 that doesn't go. Yeah, I think these are pretty much the ones. I might be skipping something here, but let's just look at the diagram. Okay, so it's gonna be 6, 7. Yes, we have 5. We have 4. Another 4 here. Okay, another 5. We have 5. Okay, let's go back to this diagram here. Okay, so these are the ones that are overlapping. Obviously, this can reach here. This can reach the Pacific Ocean from top and the Atlantic Ocean from the right over here. And then this 4 can reach, this 4 can reach, this one can reach, this. So those are the ones that are common in both the Pacific and the Atlantic Ocean. The water from there can flow to both of these oceans. So that's what the problem is asking us, to give these values, these coordinates, which are capable of reaching both oceans. So what we're going to do is let's observe the question, right? As I mentioned earlier, we're told that we know exactly where the periphery of this landmass is that's coming in contact with the Pacific Ocean and the one with the Atlantic Ocean. So let's say that I start from there because I know those are valid coordinates, and let me do something like a DFS, right? So I can do a DFS from exactly those points and start going to its neighbors, the four directions that are possible, the valid cells, and I'll keep checking. If I haven't visited them already, is it possible for me to visit them? And the possibility to visit them is that the cell, when I go from this one, has to be larger than it, because it has to be a slope, right? So if I'm starting from the bottom, I have to go upward. And if I can reach cells which are in this kind of increasing order, I'll keep visiting them, and I'll add them to like possible set, like a Pacific Ocean set. So I'll keep doing that, and I'll traverse everything through DFS from these valid cells to everything that is possible. And then I can do the same starting from the Atlantic Ocean and see all the valid cells. And then I basically just look at these two sets, and whatever is common between them, I can add that to like an answer. So let's check this out actually. So let's consider we have this, right? So this is our column 0, and this is our row 0, okay? These are the conditions for the Pacific Ocean, and we would have for the Atlantic Ocean, it would be R is equal to rows minus 1, and here column is equal to columns minus 1, right? So those would be the conditions. So let's check from here, okay? So these are our valid values, which we know are already reachable. Let's start from here. If I do a DFS and I look at all of the directions, I'll come to 2. Okay, so I know that, yes, 2 is greater than 1. Okay, so my visited, let's see, a Pacific set. And for that, 1 has already been added because it's reachable. So I would have a 0, 0 coordinate here. And 2 is also reachable because that's greater than 1, right? So I would have a 0, 1, which is added. And then I would also check here. 3 is also greater. And yeah, it's one of the valid cells as well. So that works out. So I would have a 1, 0. Then let's check from here, right? I can go here, which is also greater than or equal to it. So again, 1, 1 is added. And then I look to this side, and it's also at the periphery. So it's a 0, 2 is added. Yeah. And then I can check from here. And I would go up, and I see that's already visited. So I can just return. I don't have to do anything. I look at this side, it's already visited. I look at this side, and this one is greater than 2. And there was a valid one here. So it means this is also possible. So I would add that, which is 1, 2 coordinate. So you guys get the idea. I would continue doing this, and by the end of like doing a DFS from all of these cells, I would be getting values of all of the cells that are possibly reachable to my Pacific Ocean. And if I do the same from all of these cells from the Atlantic Ocean, like a DFS from the valid cells at the periphery, I will be able to get values like I'll get 1, which is possible, 7, which is possible. Then I'll look in these directions, it's not possible. So this is possible from here. So yeah, I go on checking like this. And if it is possible, then I add it to a visited set of like an Atlantic Ocean set here. And if it's not visible, like visitable, I just return back because it might be like possible that we can visit it from somewhere else. So yeah, basically after I do all of this, we get all the cells that are capable of being visited from Pacific and Atlantic Ocean. We'll take both of these sets, Pacific and Atlantic. We will find the common values from it and common coordinates, and we will add that to an answer. So yeah, I think I hope that was understandable, but if I code this up, I believe that it will be more intuitive. And okay, so we'll go ahead. Let's just do this, this kind of condition where if not heights, then we can return an empty list, or else we take our rows, columns, length of height. Okay, so what did I speak about? We're going to have a Pacific set and we're going to have an Atlantic set. Okay, so these will be two sets. And then what else did we have? We're going to have an answer, which will also be here. And I think that's pretty much it. Then we can define something like a DFS function here, which is going to be conquer. So what do I pass to it? I pass in the coordinates that I start from, so these valid coordinates, and then I also pass in the visited set, which in this case would be either Pacific or Atlantic. So let's call that visited here. And I need to check if it's greater than the previous cell, right? So I need to have a previous cell, which is being passed in to check that value. Now, the first thing is, if that cell has to be something that can reach and it has to be valid, then obviously we're going to do a boundary check, and we're going to also check if it's visited or not, because if it's already visited, I just want to return back. I don't want to conquer from there and repeat like in a loop. And one more thing is I have to check if it's larger than the previous value. So that can be done here if, let's say, if r is less than 0 or r greater than or equal to rows, C less than 0 or C greater than or equal to columns, or R comma C is already and visited, or heights of R comma C is less than, because greater than or equal to is fine, is less than the previous value, then I want to go ahead and return. Or else it means it's a valid option. So I'll go ahead and add that visited.add r comma c, because it's possible to visit it. And then if it's possible to visit it, then I want to check, are the neighbors of this also possible, right? So we'll have our directions. So 1 comma 0, 0 comma 1, minus 1 comma 0, 0 comma minus 1. Okay, so these are the possible 4 directions I can go in. So our new coordinate row column value would be, okay, and then I want to go ahead and I want to go ahead and actually conquer this as well. So I don't think I'm going to do any checks here because I do that over there. Yeah, so in this case, I just go ahead and call like a conquer for this new row column, same visited set, and I want to pass in the previous, which would actually be the current value right now. So I need to pass in heights of r comma c would be passed into the next one, right? And from this, I can just do a return. So this would be my conquer function, which is doing a DFS. So one thing we talked about was we'll start from the Pacific Ocean. So bring this back over here. So yeah, we spoke about like, so the left side over here is like column 0, row 0. And then for this, it's row -1, and then this is column -1. So let's do something. So we see that the row values change each time, but for these two, we see that the column values are stationary, and one is for Pacific and one is for Atlantic. So let's go ahead and write that in a kind of nice way. So we see that R is changing, right? For R and range rows, right? So let's take left side of Pacific, right? So for that, I'm going to go ahead and call the conquer function. I'm going to pass in row, and I saw that column was 0, right? And column was 0, and this is for Pacific Ocean. And also I'm passing in the actual height of this. So heights of row is varying and column is 0. Okay. And we also wanted to check this for the Atlantic Ocean. So we will do right side of Atlantic. Okay. So we want to do the conquer function again. So row is changing, and column here was the right side one. So it's columns -1. And then we're passing in the Atlantic set. And we want to go ahead and pass in height of row is varying and columns -1. Okay. So we should be able to get those values. And now the next condition was we saw these values, right? And for these, we see that the rows are stationary, but the columns are changing. So let's go ahead and do that. So for C and range columns, we'll do top of Pacific. So I can do that with conquer if row stays stationary to 0, and then columns varies. And I want to pass in the Pacific set, and my height would be for 0, comma, whatever C is varying. And then I want to do the bottom part, bottom side of Atlantic. So same, conquer. And that was actually, it was, what was it? It was rows -1, and C was varying. I was Atlantic Ocean and heights of whatever this was. So heights of rows -1 and C varying. Okay. So after I do this, I should successfully be able to populate this Pacific and Atlantic sets. So now I want to find the common values between those and add that to answer, right? So let's go ahead and traverse again. R in range rows for C in range columns. So what do I want to do? If R comma C is in Pacific and are in Atlantic, then I want to do answer dot append R comma C, right? So by the end of this, answer should have the values that we're looking for, so the common coordinates that are able to flow to both the Pacific Ocean and the Atlantic Ocean. And if I haven't made any mistakes, this should run fine, but I doubt it. Oh, wow. All right, it does work fine. I'm getting good at this writing bug-free code. Okay, so this is great. Let's analyze the time complexity over here. So this is making a call to the DFS function. This is making a call to the DFS function. Again, we're traversing through this, and basically this DFS function is at most it would go and conquer all the values in the cell itself. So this is m into n, and then 4 directions. So m into n into 4, but 4 is negligible here. And then we do that twice here. We do it twice here. For simplicity, we're going to drop those constants actually. Again, we're doing rows into column, and then we're comparing. So this is again another m into n. So that's overall everything is going to be like summation of all these times where m into n is being called. So I could drop all the constants there and write that the time complexity itself is O of m into n. And when we want to look at the space complexity here, so let's look at this. So the Pacific Ocean and the Atlantic Ocean, at max, they could have all the cells. They could probably be possible to reach everywhere. Let's say everything was unit value and it's possible to flow. So this would be an m into n, this would be an m into n, and then we have our conquer function. So technically the maximum that it could go to, because it's like a depth for search, would be like maximum of either m or n. So this is m into n from those two, the set that we're using here. And then we can do like a maximum of m or n, but this is pretty much negligible when it comes to m into n. But yeah, this is the time and space complexity, and how well. I hope you guys understood the solution. So yeah, happy coding.